The objective of this video is to show you how to solve two linear equations by graphical methods. When solving two equations simultaneously, our main purpose is to find a common solution which works for both equations. In other words, we need to find the value of x and y which satisfy both equations simultaneously. Previously, we have learned how to arrive at the solution algebraically, either by using elimination method or substitution method. However, all students should know that it is also possible to arrive at the same solution by using graphical method. Firstly, we need to plot the lines which are represented by the two equations on the same pair of axes. And this is what we can see. So, the line that crosses A and B is represented by 2y equals to x plus 2. And the line that passes through C and D is represented by y equals to 5 minus x. This is pretty obvious because from this equation we can see that the gradient is negative, so the line is going down, and this is the line that goes down. After that, we can see that this is the point where 2y equals to x plus 2 intersect y equals to 5 minus x, which means the value of the x and y at point D, which are 2 and 3, are common to both equations. So it also means that the coordinate for D is the solution that works for both equations. So the solution is x equal to 2 and y equals to 3. So let me summarize the 3 steps in solving two linear equations by using graphical method. Step 1, we need to plot both lines on the same axis. Step 2, we need to read the point which the lines cross one another. And step 3, the solution that works for both solutions is equal to the coordinates of the crossing points. Now, let's use the 3-step solution method to solve the next pair of equations. Remember, firstly, we need to plot both lines, and then we read the point where the lines cross, and we state the solution as given by the coordinates of the crossing points. So step 1, we have plotted the two lines. First line, y equals to x plus 1. From the equation, we know that the y-intercept of the line is positive 1. So it refers to the line that passes point D. So this is the line y equals to x plus 1. And of course, the other line refer to 2y equals to x plus 6. Can you recall the second step? Yes, we need to identify the point that the lines cross. And it is very obvious that point C is the point where the lines cross. So we read the coordinates of point C. It is 4 and 5. So the solution is x equals to 4 and y equals to 5. Well, let me expose you to more questions. Solve the following simultaneous equations graphically. We are given a pair of equations which are not in the gradient intercept form. So let's transform them into the gradient intercept form. 2x minus y equals negative 5. So we plus y at both sides so that we remove the y term here. And we plus 5 at both sides to remove the negative 5 here. So now, left side we have 2x plus 5 and right side we have y. And this is already in the gradient intercept form. So we know that the y-intercept of the first equation occur at 0, 5. And the gradient is 2. When this is interpreted in terms of rise over run, 2 is equal to negative 2 over negative 1. So we go down 2 units and go left 1 unit. Down 2, left 1 from 0, 5. So the y-intercept is 0, 5. Down 1, down 2, left 1. The second point, down 2, left 1. Join the points, so we get the first line. Let's do the same for the second equation. So we add 3y at both sides, and we have x equals to 3y. Then divide both sides by 3. So we have y equals to x over 3. This can be written as y equals to 1 over 3x plus 0. The 0 was ignored just now. So now I resume the value because this is the gradient intercept form. So that I know the y-intercept of the second equation occur at 0, 0. And the gradient is 1 over 3. And this is already in the rise over run form. So which means that we need to up 1 and right 3 from 0, 0. The y-intercept of the second line 0, 0. Up 1, right 3. Up 1, right 3. 1, 2, 3. Join the points. So let me take a snapshot of this. Well, look at the graphical representation of both equations. It is very obvious that The two lines are common at this point, and the coordinate of this point is -3 and -1. So the solution is x equals to -3 and 1 equals to -1. This is how we solve simultaneous equation graphically from the beginning until the solution is found. Thank you.